It's deja vu all over again. The government remains shut down, and all over again, Jared Isaacman is the NASA administrator nominee. Hey everyone, thanks as always for your time. Mr. Isaacman's nomination has returned, and it joins most of the uncertainty and unanswered questions that still revolve around NASA and Artemis. Since the president withdrew his first nomination back at the end of May, early June, as a part of the on-again, off-again, on-again relationship between the president and Elon Musk, Congress acted to preserve their plan for NASA exploration to the moon and Mars. But the clouds only parted for a moment in July. Yes, Artemis II is fully stacked and Exploration Ground Systems should be continuing final launch preparations, but that mission is the last one in the original plan that goes back way over a decade. Officially, Artemis III and the first U.S. lunar landing mission in over 50 years remain scheduled for mid-2027, but no one from inside or outside NASA or Washington, D.C. will tell us how long that flight is delayed. They're not even asking for any patience. Mr. Isaacman was only hours away from being confirmed last time, so the déjà vu extends to the feeling that confirmation is just a formality, but it remains to be seen whether the space agency will be forthcoming after that. Congress wants to win a second lunar landing race, and for a brief moment NASA agreed with them that Artemis III was delayed. But now we're uncertain what NASA thinks. Add that to the pile of uncertainty, even as the calendar continues to move, and we're only about a year and a half away from mid-2027. And with no strong signs that the government shutdown will end, we may get to exactly a year and a half from that time with little clarity about the situation with NASA or with Artemis II or Artemis III. In Artemis II Watch this week, the government shutdown continues, officially becoming the longest ever. That means we're still out of updates on launch preparations or new information, for the most part, so I'll look at some of the information we got during the briefings at the Johnson Space Center in Houston in late September. That was really the first opportunity to start to look at the mission and the timeline in more detail. 2.5 years ago, I interviewed Artemis II mission manager Matt Ramsey and got a very preliminary timeline for the very busy first day of the mission, but we don't have a detailed timeline or a day-by-day level outline. I was in the flight control room with probably at least one flight activities officer on September 24th, but those briefings weren't meant to be comprehensive, even if that would be my goal. I spoke with flight controllers at the control, booster, FIDO, and INCO positions, but that leaves several others, including the FAO, out, and by default, not enough time. Anyway, the flight crew held a press conference earlier on September 24th, and pilot Victor Glover went through the day of launch and the first approximately 24 hours of the mission.
So, the mission is 10 days, 9-point-something days, and we're going to go fly by the moon on the 6th day. I just want to share with you a little bit about the first day. And so here's a picture of the timeline, and I know that that's too small for it to be really useful to you, but I'm just going to keep holding this up here because you can at least tell that there's a bunch of different colored lines on this chart, and I'm going to talk about a few of them. And the first one is that we actually start the day that we launch 7 hours before launch, waking up in crew quarters to get medical checks and a weather brief and to work with our team to start making sure that we're ready to go out to the launch. And when the Exploration Ground Systems team and the team in launch control says that things are looking good and send their crew, we'll drive out to the pad. And so 3 to 4 hours prior, we'll start to ingress the vehicle. And then he talked about the stack weighing about 3.5 million pounds. When it's all fueled up, it'll be about 5.5 million pounds, but 8.8 million pounds of thrust at sea level. Mass flow is going to rocket us towards space. And about 9 minutes after that, we'll be in space. And then the day gets even busier. Now, we've been up for almost a full work day at this point. And so once we get to space, the ascent portion really ends after about a half an orbit when we're going to go from a 1,200 mile by 0 mile orbit to doing what we call a perigee-raise maneuver that gets us into a stable and sustainable orbit. And then we're going to get a couple of us out of our seats and start to check out really critical systems, the water system and the toilet.
Very important.
Got to have a toilet to go to the moon. And so we're going to be working as a team and working with mission control to make sure that the vehicle is ready. And then we're going to go around the Earth in about the same amount of time that the International Space Station goes around the Earth, in 90 minutes. And once we get to that closest point to the Earth, or perigee, we're going to do something called an apogee raise burn. And that apogee raise burn is going to get us going into an orbit that humans have never been in, almost 40,000 miles away from the Earth on one end. And then we'll do a perigee raise burn to get us back above 100 miles or so on the close side. But right after that apogee raise burn on the interim cryogenic propulsion stage, we're going to disconnect from that upper stage and then turn around and fly an approach to it, and we're going to fly it by hand. And we're going to make sure that the flying qualities of the Orion spacecraft are suitable for the more complex missions where we're going to dock to a lander or to the Gateway, the orbiting space station around the moon. And then once we're done with that, we're going to continue to reconfigure the cabin to make sure that it's ready for us to live and to work for the next 9 days. We're going to break down the seats. We're going to make sure the environmental control system is ready. And then we're going to monitor a few burns. And that first day, we're going to take a nap and then wake up and observe a burn in the middle of the night. We're going to go back to sleep, take another nap, wake up, and then we're going to have the lead up working very tightly with our friends here in Houston and Mission Control, leading up to trans-lunar injection. And when that team is ready and gives us the go, we're going to burn the engines and head toward the moon. And that actually happens, if you were looking at my chart, that happens on this second row right here. And that's the point where we're going to wrap that day up and actually have a normal sleep period. And so I just wanted to share with you a little bit of how busy and how many really critical things are going to happen on that first day.
Flight Day 1 is launch and insertion by the SLS boosters and core stage, and then the interim cryogenic propulsion stage makes its 2 burns, including the apogee raise burn, which is a partial translunar injection, but not a complete TLI as it did on Artemis I and will do again on Artemis III. That starts the second of 3 orbits for the mission, and then the crew performs a proximity operations demonstration after Orion separates from ICPS. I've gone through the launch events with preliminary numbers in a previous video that is linked in the upper right, and I'll also put that in the description here. A couple of years later, in late September, we got a little more detail. As we found out, the first sleep period is split in 2 with the Orion perigee raise burn in between them. Or maybe those 2 4-hour nap periods are around the PRB. Anyway, that's when Orion is out at that 40,000 nautical mile or 74,000 kilometer apogee of the second orbit. That burn brings the perigee back up to 100 nautical miles or 185 kilometers. Orion makes the TLI burn on Flight Day 2, providing the remainder of the delta V necessary to take the high point of the orbit out to lunar distance and time so that the moon is also there at that time. Later on that day, I got a chance to ask the lead flight director, Jeff Radigan, about a high-level outline of the mission after that. I probably should have started with this, but they were talking about some of these test objectives. But can you go through? Can you just kind of go through? We talked a lot about Flight Day 1 and all the things, but go through the flight days, and as an example, the crew talked about doing a radiation shelter, actually doing that. What flight day is that on? And as a part, kind of going through the flight days for the mission.
So to specifically radiation shelter is actually pretty far into the mission. I think it's Flight Day 7. And off the top of my head, I can tell you that, of course, Flight Day 1 is getting on orbit. And, Flight Day 2, the whole key there is really getting through TLI. We are going to do some checkouts of the exercise device and have that ready to go on Flight Day 2. But primarily, of course, we're trying to get through TLI. And then starting Flight Day 3, we're really going to go through all the various parts of the Orion systems and do a really deeper dive into that equipment to make sure that it works at all the boundaries. So I think Flight Day 3, the focus is really on emergency comm and ensuring that system it works. We're actually doing a checkout of emergency comm on Flight Day 1 to make sure that we have it. But then, we're going to start doing on Flight Day 3, which some frequency analysis and, trying to see if how it interferes with the S-band systems. And, once you get these things in space, you always find some surprises. And so that's what we're going to start psyching out in those systems, right? We're going to do the same thing with, our urine system. early in the mission, it's vent it, we just, continue on. Then as we get later in the mission, it's going to be, okay, how much can we store? How does it impact our guidance? We're going to start doing, again, some other things with ranging and guidance to ensure that we've got a good understanding. Flight days 4, 5, and 6, until we get to the moon, we're going to be rotating the spacecraft into a variety of thermal attitudes to see, how good was our thermal analysis pre-flight, and now what is the sensors on the vehicle actually showing us? How does that correlate? And so those are the types of things that we'll be doing as we go through the mission.
So that provides a little bit of color to the outbound leg of the mission to the moon. They will be performing flight test objectives to anchor modeling of the interactions between the new environmental control and life support systems on Orion with the other space systems that have already flown. And they'll continue to collect data on the spacecraft environment and performance in different attitudes. Normally, the spacecraft flies in a tail-to-sun attitude. And then the day after the flyby and closest approach to the moon on flight day 6, another flight test objective would be performed by the crew to set up the radiation shelter in the crew compartment. But that leaves a lot of color missing during the trip outbound to the moon and then returning after the flyby. The entry flight director, Rick Henfling, went through the entry day during the mission overview briefing.
We will come on console about the time that the flight crew wakes up on landing day. We will have a short conference with Reed and Victor and Christina and Jeremy. We'll provide them updates on the weather at the landing site and any other updates on spacecraft performance from the overnight period. The crew's going to spend their morning tearing down the toilet. They're going to deconfigure the water dispenser. They're going to put away the food warmer. Basically all the things that they set up on flight day 1, they're going to put away and stow for entry. Once the crew gets the cabin configured, we're going to perform that last final trajectory correction maneuver that Jeff talked about. This is going to put us on track for a bullseye landing in the Eastern Pacific off the coast of San Diego. Once that trajectory correction maneuver is complete, the flight crew are going to put their orange survival suits back on. They're going to do a leak check to ensure that they're leak tight for entry. That process is going to take about 2 hours to do for all 4 crew to get suited. In the meantime, while the flight crew are donning their suits, the ground team is going to be doing some final spacecraft configurations like configuring the backup flight software to perform an entry in the event of a failure of the primary flight computers. Once we get to about an hour from entry interface, that's when the pace of activity is really going to pick up. The first major activity is we're going to hand down from the Deep Space Communications Network to the Tracking and Data Relay Satellite System Network. This is the first time we'll be back on TDRS since just before the translunar injection burn. So the comm system will get reconfigured about 38 minutes prior to entry interface, at which point we'll perform a comm check, and then we will start configuring the service module for disposal. We're going to position the solar arrays in a position that's favorable for separation. We're going to perform a test firing of the crew module thrusters to ensure they're warmed up for entry. And then we're going to get into the proper attitude for service module separation. Separation will occur about 20 minutes before entry interface. And the next step will be then to maneuver the crew module into the entry interface attitude. This is to get the heat shield facing forward to take the brunt of the heat that's going to be generated on entry. Just before entry interface, we're going to perform a firing of those crew module thrusters. We're going to do a burn called the raise burn. This is going to sweeten up our entry flight path angle to ensure, again, that we get that bullseye landing off the coast of San Diego. So at 400,000 feet and about 1,775 nautical miles from our splashdown location, we'll hit entry interface. And that's when the heat of the atmosphere is going to start interacting with our heat shield, and we're going to create that plasma trail you see. This is a video from Artemis I looking out the crew module windows towards the plasma trail. The spacecraft is going to perform some bank maneuvers. It's going to roll right and left, and you can see that here in the video, to fine-tune the landing spot. Our entry guidance flight software will take care of that for us. And that's all going to put us on target for that targeted splashdown, waiting for the recovery forces. Once we get to about 325 miles per hour and about 24,000 feet altitude, we're going to start deploying some of our parachutes. We'll have 2 drogue parachutes that deploy, and then they'll bring us down to about a speed of around 115 miles per hour, at which point our 3 orange main parachutes will deploy. And that's going to bring the flight crew down to the safe splashdown velocity of 15 miles per hour. And that will be in a location right near where the recovery forces are waiting to extract the flight crew from the spacecraft.
Mr. Henfling is also the weather flight director on the ascent shift, with Judd Freeling being the ascent flight director. I got a chance to ask him some follow-ups later in the day, and I had misremembered who did what on the entry shift for Artemis I. So you were the entry flight director for Artemis I as well, and you were talking about during the briefing.
Judd was the entry flight director
Oh,
for
was he?
Artemis I.
Entry.
Yes.
Okay. Was he? Oh, he
Judd
was
did both.
ascent.
He did
Okay.
both ascent and entry.
Were you weather?
Yes.
Okay.
Yes.
I thought I saw you in the. Well then, yeah. What were you? Then?
So Judd will be the ascent flight director. I will be the weather flight director for the ascent shift.
Right.
And then we're actually going to swap seats. So I'll be
Okay.
the entry flight director, and he's the weather flight director for entry.
Okay. Were you working other shifts for Artemis I then?
Yes.
Okay. And then I was talking to a couple of the training guys. Are you doing the same thing for Artemis II? Are you gonna are there any swing shifts or anything like that?
Yeah, I've got the shift before the TLI shift. So I'll be on
Okay.
console for the nap in between the perigee Raisburn and Jeff's TLI shift. And then I've got a couple other shifts on the front end of the mission, and then the entry team will come in the day before entry and entry day. So I think I have 5 total shifts on the Artemis II mission.
Okay. For the entry, is the I guess the period from entry interface it'll be shorter through, or is the time period very similar? You don't have the skip in that. I don't know how much more time that adds.
Yeah, so
or takes
the
out.
duration from entry interface to splashdown is only going to be about 14 minutes.
Okay. Wow.
Yeah, and for 4 of those minutes, we'll be in blackout because we'll be in plasma. So the entry itself really doesn't take a whole long time to execute. It's those activities preparing for entry that are the most critical ones. The GPS solution, handing from the Deep Space Network to TDRS, positioning the solar arrays for service module separation, performing a warm-up firing of those crew module thrusters, and then the separation and Raisburn itself.
Launch and landing are always big days, and the lunar flyby will be the next highest visibility day, but hopefully there will be time before the launch to get a better outline from NASA about the day-to-day flight plan and get a better idea about how much we will be allowed to cover the mission while it is in progress. One of the questions I had going into the briefings was what kind of live feeds we could see from Orion on Artemis II. During Artemis I, NASA provided a low frame rate live stream from the spacecraft from time to time once it got beyond the Earth Orbit Communications Network. That was sometimes called sequential still video because it was only a few frames every so often. It's not clear what we're going to get for Artemis II, but the expectation was there would be something more than Artemis I, where there were several days during the 4-week-long mission where there were only a couple of minutes of live coverage. The Artemis II Orion spacecraft has an optical communication system that will be demonstrated during the mission. So one of the questions was, assuming it works as advertised, would we see something closer to high-definition live streaming on the mission? And then the next obvious question would be, how much was possible? It was addressed to some extent during the mission overview briefing.
So as we fly further from Earth, of course, Judd mentioned we'll be on the various different communication systems. When we're on the TDRS system, the Tracking and Data Relay Satellite System, we have a much higher bandwidth, and so I expect the high-definition videos that you guys are expecting from us that you see all the time on Space Station, and we'll be able to have that capability. As we go further from Earth and we have to go onto the Deep Space Network, we have a much lower bandwidth, and so we are prioritizing getting video of the crew, getting video of the cameras. If you saw from Artemis I, we of course had a video set up as we got close to the moon and had that downlinking. But it is a much lower data rate, and so our ability to transfer high-def video is significantly reduced or not even possible on certain days of the mission. And so we're going to keep the video on as much as we can, But I do want to calibrate your expectations. It's a lower bandwidth. It's going to look a little grainy, and that is just due to the distance and due to the communication assets that we have available. It turns out the moon's a pretty long way from Earth when we start talking communication signals and bandwidth, and so we just need to set our expectations there. The good news is we're recording a significant amount of video during the mission, and afterwards, of course, that'll be released.
That'll be amazing.
And I'll just add, we do plan 24/7 coverage of the mission, starting with tanking all the way through crew recovery. We've been working very closely with Jeff's team, Charlie's team, and the team that Dan supports to make sure we can show you the crew and keep you apprised of their activities.
I followed up on this the next day when we got to visit Building 30 at JSC, the Christopher Kraft Mission Control Center. I got a chance to ask a few engineers about some of the operational constraints. First, in the Orion Mission Evaluation Room. I know there's a optical communications, laser communications demo on this.
Yeah.
Is there a chance if that tests out well that you'll take advantage of that on this mission?
Oh, yes.
So, I mean...
Oh, yeah.
Because it sounded like I think they were trying to temper expectations yesterday in the mission overview briefing, and they don't want us to.
It's tempering expectations. Not that it won't work. I think we've got high confidence in the system, but depending on when you launch, the spacecraft has thermal and attitude constraints. Trey might have mentioned it in another briefing, but the way the spacecraft is constructed and the way the solar arrays are configured, we generally try to fly rear end facing the sun because you don't want to overheat the crew cabin. If you're flying rear end facing the sun, these are taken from Artemis I, but the optical comm laser system is mounted back here, so it's facing aft. So the laser can't point to Earth if your nose facing the Earth. So for example, if you launch into what here on the ground we'd see as a full moon, that means the sun's behind you. Mm-hmm. As you're flying to the moon, the spacecraft would be generally rear end facing the Earth, which means the laser system has an easy line of sight to Earth.
Okay.
But if you launch into a new moon, so depending on what day of the week or day of the month you launch, the spacecraft will be flying tail to sun, and your nose facing the Earth, so the laser comm system would require a vehicle maneuver to point the laser at the ground. Does that make sense? So it gets a little complicated. The geometry may or may not allow us to use the laser comm system as often as we would like.
Right.
But that is nothing to say the laser comm system doesn't work. It's just physics and geometry of the launch day. Sometimes you might not be able to use it when you want to.
Okay. I mean, but will there be any ability to, because obviously it also has to do with how well the solar arrays can articulate and track the sun, to get, if you're out of, because there are times where you're going to be in different attitudes than tail to sun, maybe not for a long time, but would there be, we were just over in the SUR, if you can get down a lot, if you can do like a downlink or a download session in a different attitude than tail to sun,
we
to dump that.
Yes, we very much look forward to being able to dump tens of megabits per second, which optical comm will give us compared to the radio system.
Okay.
If it's available to us, we're very onboard storage constrained.
Okay.
We can't store tens of terabytes. We don't have that kind of storage space. So if it's available to us, we're really looking forward to using it.
Is it, looking at, they're talking about the February launch period, at least that's probably the soonest that everything could be ready to go.
Yeah, that's a no earlier than.
Do you know what the geometry looks like for that in terms of?
I don't off the top of my head.
Okay.
We've got diagrams somewhere that lay all that out, so I don't have it memorized, but it will vary greatly across the month.
Okay, and then that will be the case then. They're not planning on repositioning that communications unit on future spacecraft necessarily for it to be I don't know if there is a better place necessarily than where it is. Is it mounted on the aft wall of the aft walls of the CMA?
Yeah, it's basically generally pointed aft.
Okay. So it's sort of pointed in the same direction as the sun.
If you're flying tail to sun,
Okay.
generally. I mean, it can articulate a little bit.
Okay. Thank you.
You're welcome.
As noted, most of the Orion optical comms system is mounted on the aft-facing wall of the crew module adapter. We can see the external elements of the system on the Artemis II spacecraft back in mid-March, just before the service module was encapsulated in its part of the launch fairing. In addition to those external elements on the CMA aft wall, the system also has power and data electronics inside the outer mold line on the inner wall of the CMA. The optical module part of the system is more or less facing in the same direction as the tail of the spacecraft, and tail to sun is the best thermal attitude for Orion. The optical module is steerable to some degree, but if the Earth is on the opposite side of the sky from the sun, the spacecraft itself would block the line of sight. Then, in the flight control room, the White Vicar, I got a chance to speak to a couple of the INCO controllers. INCO is the Integrated Communications Console, and that was one of the things I asked about. There were a lot of discussions going on in the room at the same time, so the background noise is a little high. How is this, what do you, maybe the best way to ask this is, how, is there a range of sort of minimum, maximum amount of, assuming it works correctly, sort of minimum, maximum amount of usage that you're going to be able to get out of that system?
Yeah, absolutely. So we are very confident the optical comm system is going to work. It is flight-proven technology. It's just new for Orion. And so really the goal of that mission is to try and provide utility and benefit to a human spaceflight mission. They've already demonstrated it. Worst case, right? And Orion has several constraints on it about how we can take it out of attitude. But if we have to be taking it out of the tail to sun attitude for use with Optical, you're looking at anywhere from an hour to 3 hours a day, which is not ideal. Best case, if the trajectory is favorable and we don't have to maneuver the vehicle, then you're limited by just the ground mass time, right? So we have 2 ground stations, both in the western United States, and that means you have roughly 8-ish hours a day of those sites in view.
We're already waiting for NASA to reach the final mission planning analysis cycle to get a launch availability calendar, so we know which days Artemis II could launch in February, March, or later. But that is probably also the earliest we can ask about the celestial geometry between the Sun, Earth, and Moon for the different launch periods, which could give us an early outlook on whether the conditions will be favorable or not for high-definition live video when Artemis II goes around the Moon. Boeing provided a few updates last week to their ongoing production of the SLS stages for Artemis 3 and 4. The Artemis II SLS vehicle, with its different elements from different prime contractors, was turned over to Exploration Ground Systems early this year, and EGS stacked the Artemis II SLS core stage back in March. Boeing is still supporting EGS for the Artemis II launch campaign, but they are concentrating on completing the third core stage build for Artemis 3, and then 3 articles across 2 stage units for Artemis 4. All the pieces of Core Stage 3 are forecast to be at the Kennedy Space Center by next spring for the final mate. In order to get there, the 5 elements have to be joined into subassemblies. That begins with the upper 4 elements, which are being completed at the Michoud Assembly Facility in New Orleans East. The top 3 elements will be stacked together vertically. The liquid oxygen tank will be stacked on top of the inner tank, and then the forward skirt will go on top of that. That's called the forward join. Boeing says that an aft join of the liquid hydrogen tank and an engine section simulator was completed in late September. Those elements were stacked vertically in Cell A of Building 110 at MAF, and then broken over to horizontal and moved back to the final assembly area of the adjoining Building 103. That's a throwback to the original core stage final assembly plan when the stages were fully completed in New Orleans. Originally, the real engine section was to be mated vertically to the LH2 tank, and then that aft join subassembly would be mated horizontally to the forward join subassembly. That plan was changed back in early 2019 ahead of final assembly of the first core stage. Instead, the forward join was the only vertical mate. The LH2 tank was mated to the forward join horizontally, and then the engine section was also mated to the LH2 tank horizontally. Now, beginning with the third build, core stage final assembly was relocated to the VAB at Kennedy Space Center. The engine section was moved to KSC 3 years ago for outfitting, and it is already in the new Core Stage Vertical Integration Center tool in VAB High Bay 2. Final assembly of the rest of the stage at MAF is now underway with the aft join completed. Next will be the forward join in Cell D of Building 110. That's waiting on final pre-stacking work on the LOX tank to be completed. After the forward skirt, LOX tank, and inner tank are mated in Building 110, the forward join will also be broken over to horizontal and moved back to Area 4748 at MAF. Then the upper 4/5 of the stage will be joined by bolting the forward end of the LH2 tank to the aft end of the inner tank. Then Boeing will complete additional internal and external outfitting of that 4/5 subassembly in New Orleans before it is ready to be barged from there to KSC next year. Engine section integration is continuing in the VAB High Bay 2 tool. Boeing is still waiting for delivery of critical hydraulic system parts after production of those shuttle parts is recertified and restarted. Boeing says they are continuing work on other main propulsion system hardware while they wait for those final components. We haven't had a chance to catch up with NASA about this, but those could be critical to the delivery date for the build. For Core Stage 4, that engine section was shipped to KSC over a year ago. More on that in a moment. The inner tank and forward skirt structures are complete back in New Orleans, but integration and outfitting work may depend on the availability of those work areas after the Core Stage 3 elements are stacked. That leaves the two propellant tanks as the final structures that need to be welded. The LH2 tank domes and barrels are currently being welded in the Vertical Assembly Center tool, and Boeing says that 5 of 6 welds are complete. That leaves the final weld of the aft dome to the barrel before the tank is a completed structure. And overall, that will leave the liquid oxygen tank as the last structure that needs to be completed. As noted, the engine sections for Core Stage 3 and 4 are in the VAB in Florida. The Core Stage 4 engine section was shipped to KSC last September, and after integration started in the Space Systems processing facility, Boeing relocated their SLS production operations in the SSPF to the VAB to consolidate the work. For the time being, the Core Stage 4 unit will remain in the transfer aisle, but Boeing is setting up a new work area within the VAB High Bay 2 footprint. A new piece of tooling is also expected to be ready for integration of an engine section boat tail assembly by that time. Once those are ready and the boat tail is shipped to Florida, the Core Stage 4 engine section will be stacked with its boat tail extension and moved into High Bay 2 with the Core Stage 3 unit. Artemis IV will be the first flight of the Exploration upper stage upgrade to SLS. Boeing is working to complete the structures and final assembly of a structural test article first, followed by assembly and full outfitting of the Artemis IV flight article. When completed, the STA will be shipped to Marshall Space Flight Center in Huntsville for testing. The EUS STA will include stage and interstage test articles. Boeing says that welding of the STA LOX tank is complete. The 2 dome-to-ring welds were completed on a welding tool at Marshall and then shipped to Michoud for the final weld in the LOX tank assembly center tool there in Building 115. After that was completed, the element joined the thrust structure and mid-body in the gray box integration area in Building 103 at MAF. The major elements of the upper stage have their own integration tools there. Assembly of the STA mid-body is nearing completion with the fit-up of the aft adapter, V-struts, and kick rings complete, and final torques in progress. The mid-body is the structure that connects the 2 propellant tanks, with the LOX tank, thrust structure, equipment shelf, and engines below, and the LH2 tank and adapters above. The final torques of the V-struts are already complete, and the final torques of the aft adapter and kick rings are in work. Additional ground test instrumentation will be added to the different elements before final assembly and after they are mated. The LH2 tank is the last element of the STA to be welded. It will go into the Vertical Assembly Center tool after welding of the Core Stage 4 LH2 tank is completed. At the end of last week, I got the chance to speak with Chris Coker, who leads the Power and Propulsion Element program at Lanteris Space Systems. NASA awarded Lanteris, previously Maxar, the contract for the PPE back in May 2019 at the front of the Artemis rebranding and reorganization of NASA's Beyond Earth exploration programs. The competition and the award was for a standalone spacecraft that was and is the foundational element of the Gateway. The element uses solar electric propulsion that allows for major translational maneuvers in cislunar space. At the time of the award, NASA's top priority had just been changed to landing the next astronauts on the moon by the end of 2024. As a part of that race against the calendar, the initial Gateway elements became something like a base camp for the Orion spacecraft and where it would meet a to-be-determined lunar lander. An initial minimal habitation element, which was planned as the second element to be independently launched, was considered necessary for Artemis III for several months until the end of 2019. The new head of the Exploration Directorate, as it was organized back then, Doug Lavero, was given the directive to focus on that top priority, which had been phrased by then Vice President Mike Pence as landing on the moon by the end of 2024 using all means necessary. And at that point, the design of the PPE began changing. Lavero decided to cut the Gateway out of the Artemis III mission, but also made another big change. He decided to integrate the PPE and the minimal HAB element, now called the Habitation and Logistics Outpost, or HALO, on the ground and launch them together in the name of minimizing overall mission risk. However, that also meant that the PPE was now going to have to serve as not only a tug for itself from Earth orbit to the moon, but also for HALO. Originally, a Falcon Heavy would launch PPE into a high Earth orbit, and the spacecraft would transit from there to the Gateway orbit, something in a class of cislunar orbits called a near-rectilinear halo orbit, or NRHO. But the change doubled the mass that Falcon Heavy would have to launch, and that PPE would then have to transfer from the Earth to the moon. The PPE and HALO together are also called the Gateway Co-Manifested Vehicle, or CMV, and together are expected to weigh 18 metric tons, which means that PPE will be starting the spiral from a lower Earth orbit. Going back to the last decade, NASA had looked at PPE concepts that would perform more of a demonstration electric propulsion maneuver, such as this one from a hypothetical SLS Block 1B launch, that would see the hypothetical spacecraft fly by the moon and make a long loop away for a 75-day transit, so to speak, into an NRHO. SLS Block 1B is still in development, and currently there is no U.S. launch vehicle with the performance or the availability to send PPE or the co-manifested vehicle on a translunar flyby trajectory. An expendable Falcon Heavy is far and away the highest performing launch vehicle that is currently available, and it was selected to launch the CMV. It will release the spacecraft in an Earth orbit of about 34,000 kilometers by 200. From there, the PPE will need something around a full year to make the transfer to the Gateway's specific cislunar halo orbit, firing its electric propulsion systems much of that time to spiral out to the moon. For Lanteris, the design changes to PPE to launch with the halo and then make the longer trip with the heavier stack are complete. The design is more or less frozen now, and they are in the final assembly and test phase. I'll go through more about the details of final assembly and test for Mr. Coker in a future video about the current status of the PPE build. In political news and notes, the big news this week was the long-rumored second nomination of Jared Isaacman to be NASA administrator. President Trump announced it on the evening of November 4th, and then it was submitted to the Senate on November 6th. In the days ahead of that announcement, there was a discussion about Mr. Isaacman's plans for NASA, at least as they stood 5 or 6 months ago when his first nomination was abruptly withdrawn. A copy of those past plans was leaked in recent days. One of the many typical oddities, so to speak, about that discussion centers around a past situation from half a year ago that is no longer the same. Back then, when the nomination was withdrawn, the discussion was about when to kill all the government Artemis programs. Some of the programs were supposed to be terminated now in fiscal year 2026, and then Exploration Ground Systems, Orion, and SLS would fly Artemis III or bust by the end of fiscal year 2027. Fiscal year 2028, which begins now in less than 2 years, would cut down funding to non-operational retirement levels to close the books on those programs. That was based on the stated premise that the Artemis III lunar landing mission would fly on schedule in mid-2027, or at the very latest could be flown in the next 2 years. But there were long-standing concerns that Artemis III was a long shot for 2027. If those programs were going to be killed by the end of that year, that's the last chance to fly it. So in that plan, either Artemis III flies on Orion and SLS in 2 years, or it waits until a commercial replacement is available, something which has no projected time frame but isn't likely until the next decade. There are long-standing questions about the sustainability of SLS and Orion, and given that sustainability was a higher priority in the budget request, an immediate commercial replacement was favored. That was back in May and early June. Mr. Isaacman was only days, maybe hours from Senate confirmation, but what will be interesting is what his views are on everything that has changed since then. We know that since then, Congress passed legislation to continue with their existing 15-year-old plan, and a race with China to have the next person plant their flag on the moon was the highest priority. The language that became law in July directly provided funding to continue the existing Artemis programs, including Gateway and the SLS upgrades that would fly on Artemis 4 and 5, delivering Gateway modules to that lunar space station. However, the law didn't provide any additional money for their lunar landing race with China. The previous 2 weeks were in discussions about that. We haven't heard either leadership in Congress or Mr. Isaacman weigh in on the possibility of funding acceleration of the current lunar landing architectures and/or funding another one. The nomination has been referred again to the Senate Commerce, Science, and Technology Committee, but as Marcia Smith noted in her story, the committee already held a nomination hearing and voted to advance the first nomination to the floor, so maybe a second nomination hearing isn't necessary. We'll have to wait and see how the committee decides to handle this. Senator Ted Cruz is the chairman of the Senate committee that will consider Mr. Isaacman's nomination for a second time, and he congratulated the nominee again in a social media post shortly after the announcement, almost immediately noting the race with China to land the next people on the moon. Looking ahead to when Mr. Isaacman is confirmed, given that assumption, some of his private plans for NASA were selectively leaked during the past week or so, and he felt compelled to provide a high-level overview after that. But we may not know which plans he wants to implement until next year when the next budget request is submitted to Congress for fiscal year 2027, which won't start until October of next year. For now, whoever is NASA administrator has to make the current plans work. We'll find out if the proposal announced by acting NASA Administrator, Transportation Secretary Sean Duffy, to look for lunar lander alternatives remains on the table or not. The proposal was to look for alternatives that can make a crewed landing attempt by the end of Trump's term, but we still don't know how far behind the mid-2027 Artemis III schedule Starship HLS is. An obvious question is whether Mr. Isaacman will finally provide some clarity about that. Artemis III was set as the agency's top goal back in 2019 and remained that way through the last 6+ years. He agreed that the current plan was the fastest way right now to run the Artemis III relay race during his April nomination hearing, while simultaneously noting the sustainability problems with SLS and Orion that the administration then cited in May when canceling those programs in their budget request.
Do you believe that the current Artemis architecture featuring SLS rocket or Orion spacecraft is the best and fastest way to beat China to the moon?
Senator, this is the current plan. I do believe it's the best and fastest way to get there. I don't think it's the long-term way to get to and from the moon and to Mars with great frequency, but this is the plan we have now, and we've got to get this crew around the moon and the follow-on crew to land on the moon.
Thank you. Thank you, Mr. Chairman.
A U.S. lunar landing in the next 3 years would become his responsibility after confirmation. We know that Congress still endorses that as NASA's top priority, and we'll have to see if Isaacman and the White House remain as enthusiastic as Mr. Duffy became in September and October. Thanks for watching. Like and subscribe if you find these videos informative and want to find out what's going on with Artemis every week. Big thanks, as always, to the members of this YouTube channel who are helping make it possible to keep doing this. I am posting additional content and updates if you're interested in joining. If you're willing to make a one-time donation to help support what I do, I would really appreciate it. I put a link to my Buy Me a Coffee page in the description. Thanks again, and I'll see you next time.